Everyone thinks chromatography is simple and foolproof. You just spot the ink, dip the paper, and the colors separate. But the truth is, it only works because of some important assumptions. Students need to understand that things can be both assumptions and limitations. However, if we write something as an assumption, we cannot also write it as a limitation. You cannot guess something is true and helpful, but at the same time know it causes problems. Assumption 1 is that the pigment is soluble in the solvent. This is important because if it is not soluble, it will not move, and you will just get a blank strip. Choosing the wrong solvent for the pigment causes this mistake. Assumption 2 is that the pencil line and everything holding the paper up is insoluble in the solvent. This matters because if you use a pen, the ink will dissolve and spoil the results. Assumption 3 is that the paper allows even capillary action. We expect the solvent to rise smoothly through clean and uniform paper. Poor quality paper can disrupt this flow and cause problems. If you are familiar with the paper, you can assume it will not affect the results. Assumption 4 is that each pigment moves on its own without reacting with others. Some inks contain mixed dyes that can overlap or interact, causing confusion in the results. Assumption 5 is that the solvent stays pure and does not evaporate too fast or react with the air. If the solvent evaporates quickly or gets contaminated, the separation will be affected. Assumption 6 is that the solvent can separate pigments based on their polarity. You need to pick the right solvent that matches the pigments. Using the wrong solvent means pigments will not separate. Assumption 7 is that the solvent front travels a measurable distance. It should move enough but not run off the paper. If it runs off, you cannot calculate the RF values. Now, about limitations. These are problems that happen even if your assumptions are correct. One limitation is the size of the spot you put on the paper. If the spot is too big or too dark, the pigments will bleed and smudge, making the results unclear. Another limitation is the environment. Things like humidity, temperature, and air movement affect how fast the solvent moves and evaporates. Timing is also a limitation. Leaving the paper too long can cause the solvent to evaporate or the pigments to change. Solvent control is important too. If the solvent rises too fast or too slow, the separation will not be clear. Finally, reproducibility is a limitation. Even small changes in the setup can cause different results each time. There are also sources of error, which come from mistakes or things out of your control. Using a pen instead of a pencil causes ink to mix with your sample and gives false results. Choosing the wrong solvent makes the pigment stay put and not move. Spotting unevenly or using too much sample causes streaks instead of clean dots. Letting the solvent touch the spot directly washes the pigment away before it separates. Forgetting to mark the solvent front means you cannot calculate the RF values later. Using dirty or reused paper causes contamination and false spots. Remember, some things can be assumptions or limitations. Depending on how well you control the experiment, if you take precautions, some limitations become assumptions, but if an assumption is wrong, it turns into a source of error. Limitations are usually things you cannot easily control. So chromatography is not just a coloring activity. It is a chemical process that relies on careful assumptions and can easily be affected by small mistakes. To get better results, use the right solvent, spot carefully, avoid contamination, and always use a pencil for your baseline.